This is a Kzubr Migmama 400. Doesn't even have the name. Anyway, so Migmama. It's got current, it's got voltage, and it's got thrust control. Problem with the product is that the owner had the positive touch with one of the contact wires for the switch for the wire feed and the gas. And when it was brought to me, the motor would run at full speed, and then the gas valve, which is located back here, would just run continuously. What I did was, as you can see here, chopped it off mostly. And yeah, let's go over the schematic real quick. So, first of all, you have on any 555 speed control. So this is the values I went with, and that's about it. Sorry for the flicker. It's common as fuck. I just use but I had to galvanically isolate this. That's the funny part. The only reason this video is being made. As you can see, this is the output choke. On the output choke, this wire is wound, goes to a bridge rectifier, and then goes, and that is actually what is powering the little motor. Motor is a 24-volt motor. This gives 40 volts under load. Anyways, so I had to galvanically isolate the switch from the motor driver from the gas valve, and had to have them all turn on simultaneously whilst having speed control. So speed control goes to an optocoupler. Then this is the interface for the switch. So what I did was, as usual, just get a shitty power brick. This one is a 7-volt 200 milliamp from a vacuum cleaner charger. So here is the isolated one, and then that's the gun. You put in a diode here, a fuse here, 22 ohm here, and then a shunt regulator with a MOSFET. So it's the PCB. I'll show that in the end. So Zener diode to the base. Once you get over voltage, over 7 volts or so, this turns on, shunts the voltage, protects the opto, the fuse blows, and then I just put the fuse here. There is a spot where another meter is supposed to go, but it's not used, so I just drilled a hole, put a fuse. Simple. After that, this is the actual motor output circuit. So I take get a pointing device. That's the opto from the 555. That's the 40 volts DC. I put a diode in series and put a cap so that when the motor runs, it does not discharge the capacitor. Then I go through a 1K and then another 1K. Gives me 20 volts, a 15-volt Zener, and then that just gets fed via the optocoupler transistor through a 10 ohm to the MOSFET. MOSFET has a 10K pull down, drives the motor, and then this is the relay. So 40 volts DC plus goes straight to the motor, minus gets chosen between speed control or this 0.5 ohm resistor. Why? Because we want the motor to stop instantly. Very important. and then 24 volts positive goes to the gas valve, and that's it. It's just to show you the implementation. So I've got the relay, 24 volt Finder relay with the resistor on a separate board. Not sure why, honestly, I swear to God. Anyways, here is the board from the bottom. As you can see, it's completely handmade, but it's not the best. Yeah, copper a bit too thin. Anyways, this was a shitty off-cut board that I used. I think that's why. So here you can see all the shit. The big transistor, the transistor that I use to protect the voltage. These I of course stole from the actual control board, because why would I pay for transistors when I don't have to? It's a 7812 regulator. It's the voltage divider that creates the voltage for the opto. The opto is socketed, the 555 is socketed, the other opto is socketed just in case. And yeah, that's the 22 ohm resistor. Protection diodes, I did double them up so that they're like 2 amps, but because the fuse is half an amp, so just in case the user decides to put some wire, although it should be fine. Well, that's it, pretty much. The potentiometer is like this. Looks kind of neat. It's actually a pretty good quality pot, I think. That's about it. That's Kzubr. I'm not sure why they didn't go with separate supply to galvanically isolate this the switch. It's very dumb. They have like 4 power supplies here. Like, look at this. They have this control board that creates 24 volts, then it has plus 15, minus 15, and then it's got another SG352 chip or whatever, and then these 2 MOSFETs are also used to create some other supply. It's got an op amp here. It's got like 2 op amps and some switch, and it's got the funniest part of all. It's got a 32-bit microcontroller and then an 8-bit microcontroller. Let me just... see that shit? It has a fucking 32-bit micro, and I'm not sure why. The power board looks like absolute garbage, hot trash, and they made probably hundreds of thousands of these. Isn't that cap right there? That's just floating on thin air. Cap right here also just has the leads stuffed through the board and soldered. Absolutely disgusting. That's the soft start. The soft start here is not with a varistor, it's instead just run by this 24 volt power supply. When this turns on, the soft start disables, but it doesn't have that many capacitors. This device claims, I think it claims 400 amps. In reality, it should be about 120. Look at this shit. Mid 400 amps. Where's my finger? 400 amps. Absolutely hilarious. But anyways, that's about it. Thank you for watching, and I will see you next time.